Hi everybody, this is Miss Frazita. We're doing 3.5, derivatives of trig functions. So I went ahead and just kind of started right off the top with what they are. So we have 6 trig functions, and therefore we have 6 formulas to remember. It sounds like a lot, but you use them so often you will memorize them without a whole lot of effort. But initially, it may seem like a lot. So derivative of sine is just cosine. Derivative of cosine is negative sine. Well, you know what? I guess you can read through them. I guess one thing that I would recommend, or try, I guess a helpful hint in trying to remember them, is if it starts with the letter C that you're taking the derivative of, the answer should be negative. So for the cosine, cosecant, and cotangent, those are all negatives, and the other 3 are all positive. Okay, let's just give them a try. So first example at the top, we would have a function that looks something like this with our trig functions in it. And it is a quotient, so we're going to apply quotient rule. So you have the bottom, which is this part, derivative of the top. Derivative of cosine is negative sine, minus the top, cosine of x. Derivative of the bottom. So derivative of 1 is 0, derivative of sine is cosine, all over the bottom squared. And of course you could simplify this, but that's not really the point of this right now, so I just left it. Okay, the second one, y equals secant theta cotangent theta. This one I put in because I thought, gee, if you think about simplifying it algebraically first, you can do quite a bit with it, and then taking the derivative won't be so hard. Otherwise, if you didn't think about simplifying it algebraically first, you might have to do a product rule, or I guess you would be doing a product rule. So if I want to try to get out of doing product rule, secant can be 1 over cosine, and cotangent, excuse me, can be cosine over sine. The cosines, of course, cancel. I get 1 over sine, which I rewrite as cosecant. So again, this is just algebraically simplifying it to something that equals it. And now I just have cosecant. So the derivative of cosecant is our formula, negative cosecant theta cotangent theta. I didn't have to do product rule. Okay. So here's one that sounds kind of a familiar setup. It's find the points on the curve, y equals tan x, where the tangent is parallel to the line y equals 2x. Okay, so if we want it to be parallel to y equals 2x, that's just a line, its slope is 2. So really, we know that we want the slope to be 2. So we want to find the points on this curve that have a slope of 2. So the slope of this curve is given by the derivative of it. So take the derivative of tangent, that's secant squared, and then set it equal to 2 if we want it to be parallel to this other line. So that, sorry, oops. So then when we have it equal to 2, we're thinking, okay, I want secant squared of x to equal 2. If I square root both sides, I get plus or minus root 2 is secant x. And then if I take reciprocals of both sides, reciprocal of secant is cosine, and reciprocal of root 2 is root 2 over 2. And then I have to think on my unit circle, as I put over here, what angle has a cosine of root 2 over 2 or negative root 2 over 2. So pi over 4 and negative pi over 4 are the answers on the unit circle that are in this given interval that was initially stated in the problem. Okay. Oh, okay, so we've talked about velocity and acceleration and distance, but now they're talking about jerk. Hardly ever see this, but jerk is going to be the derivative of acceleration. If you come across it, you just know it's another derivative. Okay, so here are 3 practice problems I'd like you to go ahead and try. And as before, when you're working out your practice problems, pause it, try them yourself first, and then go ahead and hit play to see the solutions. And this time I wrote out the solutions by hand, but that's okay. You should still be able to see them. Okay, go ahead and try them and pause. Okay, so the first one, we want the equation of the line that's normal to the graph. Normal, remember, it means perpendicular. So I like to kind of start with the end game, so to speak. So we want the equation of a line. Here's my equation of a line. And they gave me at the point specifically when x is pi over 4. So I know I plug in pi over 4 there. And I might as well go ahead and just get the y coordinate while I'm at it. So since this is the equation for y at pi over 4, I can plug that in. Tangent of pi over 4 over pi over 4. Tangent of pi over 4 is 1. Yes, you should have that memorized from your unit circle. So we get 4 over pi. So the only thing that's missing really is our slope. So I know that my derivative is going to be the slope. So my function is tan x over x. That's a fraction or a ratio. I need a quotient rule. So bottom derivative of the top derivative of tangent is secant squared minus the top times derivative of the bottom. Derivative of x is just 1. So tangent of x times 1 over the bottom squared. Now specifically at the point pi over 4, what is the slope? So I go ahead and plug pi over 4 in. Algebraically simplify it down. I got 0.925. Oh, and you know what? I forgot to take normal to that. It should be 1 over 0.925. Normal line is perpendicular, so opposite reciprocal. So negative 1 over 0.925. I'm sorry, you guys. So make sure you change this slope to the opposite reciprocal, negative 1 divided by 0.925, whatever that is. I guess I was in too big of a hurry. Okay, and then the second one asked you to prove that the derivative of cotangent is negative cosecant squared of x. So cotangent, if I rewrite it algebraically, it's cosine over sine. And then I think quotient rule. So bottom, derivative of the top, derivative of cosine is negative sine, minus top, derivative of the bottom, derivative of sine is cosine, all over the bottom squared. I simplify it to here, I factor a minus sign out, and then I see Pythagorean theorem right in here. So sine squared plus cosine squared is 1. I plug that in, and sure enough, I have negative cosecant squared x. I proved it. Okay, let's try number 3. This one. Zoom in a little bit here. Okay. So basically they gave us this function, and they just want us to find velocity, speed, acceleration, and jerk when x is, or t is, pi over 4. So my first derivative, derivative of sine is cosine, derivative of cosine is negative sine. And then at pi over 4, I just plug the pi over 4's in, and the cosine and sine of pi over 4 are both the same thing, so that subtracts to 0. Speed is just the absolute value of velocity. Absolute value of 0, of course, just 0. Acceleration, I go back to my first derivative for velocity here, and I take the derivative of that. So derivative of cosine is negative sine. Derivative of negative sine is negative cosine. So I get this for my derivative. I plug in pi over 4 again. I get negative root 2. If I then go ahead and take a look at my acceleration equation and take the derivative of that, I'll get jerk. So here, negative sine derivative will be negative cosine t plus derivative of cosine is negative sine, so negative of negative makes it a plus sine t. I plug in the pi over 4, it came out 0. And that was our last one. Okay, thank you.